Hello, algebra students. Mr. Lawrence here with your next flip lesson. And we are going to be doing something called graphing using slope-intercept form, or you'll often hear me refer to it as slope y-intercept form. You'll see why in a minute. But you see, I have an equation over here, y equals 2x minus 1. And I've made a t-table. I've pre-selected my x's. And I'm going to go ahead and figure out the y values. If I put 0 in for x, I will get -1 out. If I put -2 in for x, I get -4. Minus 1 is -5. And then if I put +2, I get 4 minus 1, which is 3. I'm going to go ahead and plot those points. Let's see here, -2, -5, 1, 2, 4, 5. Looks like it's right about there. All right. And I'm going to clone him a couple times. That's not where those points are on the graph, but I will go ahead and put them where they go. So I need a point. I already have a point at -2, -5. I need one at 0, -1. So I'll put one there at 0, -1. And then finally I need a point at 2, 3. 1, 2, 1, 2, 3. All right, I'm going to go ahead and draw my line. And let's see here. I think my line is gonna look pretty much like that. Let me change a couple things about it. There we go. I like the way that looks. Now, do me a favor. Would you find the slope of the line? The slope of the line. You can do it either by subtracting, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or you could do it by counting. I mean, you could count. You could go from this point and say, let's see, I'm going up 1, 2, 3, 4, and then over 1, 2. You could do it that way. So it looks like the slope is going to be up 4 and over 2, both positive, and better simplify as 2 over 1 for a slope. Hey, wait a minute. Look at this. Huh. That's the same number, isn't it? Well, I'll be. Notice I'm noticing something else. You see this point right here in our t-table? 0, -1. 0, -1 is what we call the y-intercept. It's the place on the graph where the line crosses the y-axis. To intercept is to go across something. And that point is right there. Right? And the reason I think that's kind of strange, if you can tell by the tone of my voice, is look at this. Once again, they match. Look at that, a -1 and a -1. This is no coincidence. When you have y alone, did I mention y must be alone? The y must be alone. Y must be alone for this to work. If you have the y alone in a linear equation, you are in what's called slope y-intercept form, or slope-intercept form. And it looks like this: y equals mx plus b, and the m, or the coefficient on x, is your slope. They use m because it's the movement. Remember, slope is rise over run. So m is your movement. And then the b is your y-intercept. And remember, I'm not sure what happened there. There we go. The y-intercept. They use b because it's the beginning of the graph. It's where you begin to plot your points. And I'll show you how to use this in a minute. Remember, the y must be alone for this to work. Now, what I'm actually showing you is I could have graphed this line without making a t-table because the y is alone. And let me show you how to do that on this problem here. Okay, first thing I'm going to do is ask myself, is the y alone? And sure enough, y is totally alone. Well, then I'm going to find my slope. And my slope is the coefficient in front of x, and in this case, it's -1/2. All right, and then I'm going to find my y-intercept, my beginning. That's the number that's added or subtracted to x. And in this case, the y-intercept is 5, or as a point, we could say that has 0, 5. We need the x-coordinate to be 0, because if it's not, then I won't be on the y-axis. I don't know if you realize this, but every single point on the y-axis has an x-coordinate of 0. All right, now watch how simple this is. I'm going to go with my b, my beginning. I'm going to go to the y-intercept and go 0, 1, 2, 3, 4, 5. There is my first point. Now, I'm going to do my movement. I'm going to rise -1, and I'm going to run 2. So, I'm going to go down 1, run 2. Down 1, run 2. Down 1, run 2. I don't know about you, but I think this is way easier than making a t-table. Oh, a t-table is a good place to learn. It's a good way to start. But now that I know if the y is alone and I have a linear equation, I certainly can just find the slope and the y-intercept and plot those points that way. Now, by the way, you might be wondering, what if I thought about this -1/2 as 1 over -2? Because they should equal the same thing. Well, watch this. I'm going to go back to the y-intercept. And now my rise is a +1, and my run is a -2. So I'll go 2 in the negative direction. And look at that, I'm still on the line. If I go rise 1, back 2, I'm still on the line. Well, I'm ready to draw my line, and it will look something like that. Of course, I need to make my line have arrowheads on both sides, and I want to take up most of the graph. But look at that, I have 1, 2, 3, 4, 5, 6 points plotted on this line with doing very little math involved. This is way easier. Gotta make sure the y is alone, though. Have I said that enough times? Let's take a look at this equation. The y is definitely not alone. But I can solve for what? Remember a couple days ago you solved some literal equations. I'm going to get y alone. So my first step will be to subtract 3x from both sides. Please be careful on the right-hand side. Do not make any pineapples. The left-hand side, these cancel. I get -2y. And then on the right-hand side, I get -3x plus 8. Okay. Well, y is not alone yet. I have this -2 here. So it's attached by multiplication. I'm going to divide by -2. I'm going to divide by -2. And I'm going to divide by -2. All right. My left-hand side simply becomes y. My right-hand side, the two negatives will cancel. I'm going to get 3 over 2x. And my left-hand side will simplify to -4. Now that the y is alone, I can tell you without a doubt my slope is 3 over 2. My y-intercept is 4, or as a point, that'll be 0, 4. So I'm going to plot the point 0, 4, 1, 2, 3, 4. And now I'm going to rise 3, run 2. Rise 1, 2, 3, run 1, 2. Rise 1, 2, 3, 1, 2. If I want, I could use a slope of -3 over -2. Always from the y-intercept, never from the origin, unless the origin is the y-intercept. So I'm going to go down 1, 2, 3, back 1, 2. 1, 2, 3, 1, 2. If you ever seen me graph something in class, I might have mentioned that I was cheating in some way. And what I meant by that was I was actually using a method that you didn't know how to use. 2, 3, 1, 2. Here we go. And this is the method I was using. So hopefully you're finding this to be really simple. We'll get some practice with this in class. Have to be really good at it because you're going to be graphing a lot. And let me see here. That doesn't show very well. That one does. Okay. And maybe I can make it a little bit longer. And there you go. Okay, it's easy that. But remember, the y must be alone for this to work. Okay. All right, I think that's it for today. Mr. Lawrence signing off. Good night, everybody.